Okay, so right at the end of the last video, we were calculating the final answer for number 6 on the back of your sheet, the more torque questions, and assuming you can punch it in your calculator correctly, you should get 67.44 kilograms. Okay, one of the questions that I'm going to get you, I think you need to do another one of these, so before this video is over, I will give you numbers for another one of these, just so you can try it on your own, because watching me just isn't the same thing. But now, the moment I've been alluding to but not doing it, and that moment is, it's time to do a question where there's friction at the top of the ladder. Now, it's a little bit tricky, and if we were doing this in class, after I set it up, I would make you do it before I did it. So partway through here, I'm going to say stop the video and see if you can finish it. Or at least go until you get stuck, and then restart the video. So it's a 16 kilograms, so the mass of the ladder is 16 kilograms. 10-meter long ladder, so this distance is 10 meters, and it's uniform, which means FG of the ladder is going to be halfway along its length. It's leaning against a building, creating an angle down here, 70 degrees. An 80 kilogram person is 4/5 of the way up. So this is FG of the person, and the mass of the person, it tells us, is 80 kilograms. Okay, so wait, maybe if I go out a little, you can see the whole thing for a second. So 16 kilogram, 10-meter long uniform ladder leaning against a building, creating an angle of 70 degrees. The 80 kilogram person makes it 4/5 of the way up the ladder before it begins to slip. So 4/5 of 10, which is 8. If the coefficient of friction at the top of the ladder in the building is 0.2, what must be the coefficient of friction at the base? Okay, so we have our R of the person is 8 meters, 4/5 of 10, and the coefficient of friction at the top, so with the house, is 0.2. And you're looking for the coefficient at the ground. Okay, so we have, now I'm going to make it bigger now that you saw the question. So we have down here F normal of the ground and F friction of the ground. And up here we have F normal of the house, and this will be friction of the house. And it will act up because if the ladder were to slip, it would slip downward. So you still start in the same spots, do some of the forces in the Y direction, and it's not slipping, so this should be Y. So it's going to be F normal of the ground going up, and also F friction of the house is going up. And going down is FG of the ladder and FG of the person. Nothing has changed. You still want to find an expression for the normal of the ground. So F normal of the ground will equal M of the ladder G minus M of the person G, minus F friction of the house. Now you want to be careful here. You don't want to sub in too much. So for right now, just leave it like this, okay? Or I guess if you want, you could go F normal of the house. Yeah, no, I would wait. Sorry, and it's not house, it's ground there. That house got mixed up. F normal of the ground. So if you wanted, you could do M of the ladder G plus M of the person G minus mu F normal of the house. Okay, but you have to be careful because you can easily get stuck in an endless loop. Stop there, you can't find it. Go over to the X direction. Sum of the forces equals MAX. AX is 0. There's only 2 of them. F normal of the house, F friction on the ground equals 0. So like we found before, F normal of the house equals F friction on the ground. Okay? And I would suggest you halt there. The danger is you could sub this in here, right? You could put F friction of the ground where the normal of the house is, and then you could say, oh, friction of the ground, though, is mu Fn, and this is the Fn, and that's where you get caught in an endless loop. So don't do it, okay? Instead, go to sum of the torques equal to 0. So a torque from the normal on the ground, a torque from the friction on the ground, a torque from the normal of the house, a torque from friction on the house this time, a torque from the ladder, a torque from the person. Don't change your pivot point on a tough question. Keep it in the same spot. The normal of the house and the friction of the house are both going to make it rotate clockwise, counterclockwise positive, the other two negative, these two to 0. So positive, positive, negative, negative, and it would be somewhere about here. I would say stop the video, see if you can solve it, and then restart me. Okay, so stop. And then if you restart, so it'll be R normal of the house, F normal of the house, sine theta normal of the house, plus R friction of the house, F friction of the house, sine theta friction of the house, minus R of the ladder, M of the ladder, G, sine theta of the ladder, minus R of the person, M of the person, G, sine theta of the person equals 0. Okay? Now, right here is where you should sub. Friction of the house is equal to mu F normal of the house. Sub it in that one spot, because then you'll have two terms with F normal of the house. Take the other two terms over. So R normal of the house, F normal of the house, sine theta normal of the house, plus R friction house, and then mu house, F normal house, sine theta friction house, and on the other side, R of the ladder, M of the ladder, G, sine theta of the ladder, plus R of the person, M of the person, G, sine theta of the person. On this side, I don't know about you, on this side, pull out F normal of the house. And so it'll be R normal of the house, sine theta normal of the house, plus R friction of the house, mu house, sine theta friction house. And then you're going to divide by the bracket. The other side stays the same. So F normal of the house equals R of the ladder, M of the ladder, G, sine theta of the ladder, plus R of the person, M of the person, G, sine theta of the person, divided by your bracket. So R normal of the house, sine theta normal of the house, plus R of friction house, mu house, sine theta friction house. And now fill in your numbers. How are we doing for time? And we might actually get to finish this. So F normal of the house. R of the ladder, it said it was 10 meters long and uniform, so 5 meters. The ladder's mass was 16 kilograms times 9.81 meters per second squared. The angle for the ladder, 20 degrees, because the angle at the bottom was 70. Plus R of the person, 8 meters we had decided, 80 kilograms, 9.81 meters per second squared, and the angle also 20, divided by R normal of the house, the full length of the ladder, 10 meters. The angle for normal of the house. This is 70, this is 70. And now the other angle is going to be this whole thing. So it's going to be 70 plus 90 when we get there. Okay, so sine of 70. R is still going to be 10 meters. Mu was 0.2. And this angle will be sine of 160. Carefully punch this into your calculator. And you should get F normal of the house to be 239.635 newtons. Once you have this, now you can find friction of the house, because it's just equal to the mu of the house times this. So 0.2 times that, which should be, move the decimal and multiply by 2. So 47927 newtons. Take these then and fill them back in up here to get your normal of the ground. And then once